Hello and welcome to this course where we're going to be concentrating on microservices with Spring Boot. This course has three objectives. If you're new to microservices, then I'll be giving you a feel of what microservices are all about. And as with all of our courses, you'll be getting plenty of hands-on experience. We'll also be using Spring Boot in anger. By the end of this course, we're going to have 5 or 6 separate Spring Boot projects. You can use any language or platform to build microservices, but Boot is very well suited to the task, as I hope to prove on this course. But if you're not interested in Spring Boot, then no problem, you'll still find the exercises valuable. And we're going to be using a suite of components provided by Boot called Spring Cloud. These are a great kind of management suite for microservices, and they're based on work done by one of the pioneers of microservices, the Netflix development teams. Again, even if you're not planning on using Spring Cloud Netflix in your production work, it's still a great way to get some experience in the kinds of problems you're likely to face in microservices and why some kind of management software is definitely needed. In this chapter, I'll be doing a nice high-level overview of microservices. You can skip the rest of this chapter if you're already familiar with them and you just want to get cracking with Spring Cloud. Then we'll take a bit of a diversion because messaging is a useful aspect of many microservice architectures. We'll see how to send and receive messages from a queue in Spring Framework. I should have covered this on other courses by now, to be honest, but I haven't, and I'm going to make amends for that now. But then we'll start the focus on microservices. We'll need a whole chapter where we're going to work on getting a small group of microservices to collaborate, and then we can finally get to work with Spring Cloud. We will be covering Eureka for service discovery, Ribbon for load balancing, Hystrix for fail safety, Feign to make our REST calls clean and efficient, and Spring Config so we don't have configuration data scattered all over the system. It's 7 hours of intense work, so I hope you enjoy the ride. Let's start with that high-level overview. Well, microservices is certainly a topic that has seen a dramatic rise in interest over the past, well, at the time of this recording, it's the past couple of years. You can see from this Google Trends graph that sometime around the start of 2014, there was a sudden rise in interest in this topic. So what is microservices all about? Well, the easiest way to explain this is to contrast a microservice architecture, the one that we're aiming for on this course, with a traditional architecture. And commonly, we call these traditional architectures monoliths. A monolith you'll probably be familiar with. This is where an entire system is deployed as a single unit. If it's a Java web-based application that we're talking about, then that would be a single WAR file. Now, unless this is a very simple application, the WAR file won't be just fulfilling one business need. It will probably be fulfilling many, many business requirements. I'll go for an easy example. If this was a shopping site, then inside that WAR file, you would typically find code for things like shopping cart management, catalog management, sales, inventory management, authentication. We'd have some kind of back-end administration. We might have a reporting facility, and that would go on and on and on. I'm sure that you've worked on one or many of these systems in the past, and of course, the natural thing is that over time, they get bigger and bigger and bigger, encompassing more and more different business requirements. And usually, of course, there will be a global database backing this application. And all of these business areas would typically be able to read and write to that database schema. That's not always the case. The schema could be broken up into separate schemas, but it is common to have one of these global databases. And often, this database might even be shared with other monolith applications. A very common term for this type of database is an integration database. So all fairly straightforward. What's the problem here? Well, of course, the monolith gets bloated. Eventually, it gets too big to manage easily, and it gets harder and harder to make changes to one business area without you accidentally breaking another business area. It gets harder to coordinate. By the time the monolith gets this big, we're going to have multiple teams working on this application. And those teams are going to start cutting across each other. So if I want to make a change here, then I've got to consult with colleagues from the other teams to make sure that I'm not impacting on them. And we also end up having to delay any new releases of the application until such time as we're able to coordinate a release of the entire monolith. Let's say I've made a change here, but that's required a change to a bit of code over here and a bit of code here. So I can't release my code until the code here and here has been upgraded. So by necessity, we have to have some kind of a big build process where the releases are coordinated. And it's often the case that days or weeks pass before we dare to do this big bang release of the monolith. Well, the solution to this is pretty natural. It's just good engineering, really, and it's the kind of thing that as an industry we've been talking about for years. You can really think of microservices as just being an extreme form of modularity, of building the system as a set of self-contained components. Now, that would have been the term that I traditionally used to describe this kind of architecture, but now microservice is very much the buzz term. But you could think of a microservice as being a component or a subsystem. And the key thing is that these microservices can function on their own. They can be deployed on their own, and they can be developed on their own. But these microservices can, of course, communicate with each other through well-defined interfaces. By the way, this picture is a fragment of UML, and the symbol here, I don't know if you know, represents a UML component, and I think that fits with the concept of a microservice perfectly. I've probably used diagrams like this for 10 years or more on courses and at work. But the big idea in microservices is that this separation is going to be extreme. Traditionally, I would have probably built these components as separate Java packages, but ultimately I would have combined all of the code together into one great big WAR file. Packages are really weak. They really don't give any serious level of separation, and certainly not at runtime. So these microservices are going to be developed in their own workspaces, and most importantly, they're ultimately going to be deployed to their own standalone hardware. If we can afford it, we would have each service would be running on its own private physical instance of a server. Well, actually, that could turn out to be quite expensive. So in practice, the microservices would often be deployed to their own containers, which is a sort of virtual machine instance. You might be familiar with tools such as Docker, and Docker enables us to divide up a physical hardware server into multiple containers, which are highly separated. They're like small virtual machine instances, and we can put one microservice into each container. Now, I'm getting ahead a little bit there, and we will be covering that in detail in the follow-on to this course, where we will be deploying the code that we write in this course onto some real hardware. But I think the point I want to get across here is that each microservice is going to be for its entire lifetime through to its deployment. It's going to be really self-contained. The code in one microservice is going to have no direct visibility of code in another one. Now, of course, there's got to be communication between them, so there will be interfaces. And there are a lot of options here. Traditionally, REST calls are used, but you can also have messages passing between them. We're going to be doing both of that on this course. On future courses, we'll be looking at how we can use more advanced features such as Spring integration, streaming, and reactive technologies to get even looser coupling. But for this course, we're going to keep things simple to establish the basics, and we will use REST and messaging. So in many ways, there's nothing new here, but the reason that microservices is getting a lot of attention right now is that some of the major internet real estates, and the one that I have in mind particularly is of Netflix, but there are many others as well, they've really taken on board some very bold and extreme working practices, and they've also been very good at talking about what they're doing with the larger IT community. So at one level then, microservices are easy. We just architect the system as a set of small services, and each of these services will be responsible for one, and if possible, only one business requirement. Well, I'm being vague about what business requirement means. That's going to be up to the architect to decide. And to have a microservice only dealing with one single requirement is something of an ideal. But we have some rules of thumb here. We'll talk about this in a bit more detail later on in the course, but one rule of thumb that you might have heard of that many companies are adopting is the idea of the two pizza rule. Well, it's a little bit cute, this one, and apparently it originated from Amazon. It was in fact an idea that Jeff Bezos, the CEO of Amazon, had in order to keep his meetings focused and small. And it's something that the Amazon developers, when they're coding their microservices, have adopted. And the two pizza rule simply means, can we feed the entire development team for this microservice using just two pizzas? Well, okay, as I say, it is a little bit cute. They don't say how big the pizzas are, but I hope you get the general feel for what we're talking about there, that the microservices are going to be very constrained in their size. If you start finding that you have 4, 5, 6 developers who need to work on a microservice, then it's definitely too big and it's time to break it down. I'm going to keep saying my rule of thumb is that a microservice should be dealing with only one specific area of business functionality. I recognize that that's vague, but as architects, we have to use our judgment on a case-by-case basis as to where the dividing line is. At what point do we break a microservice down into multiple microservices? So keep that in mind. We will keep returning to that theme, but I really want to highlight the fact here that it really is possible to have a microservice that is just a few lines of code. Another chief concern with microservices, and again, this is just good design, it's good architecture that we will have discussed on many previous virtual pair programmers courses, is that each microservice should be highly cohesive and loosely coupled. These are two of the most important principles in software development and very relevant to microservices. Let's look at each of the principles. Highly cohesive. Well, I've already really covered that by saying that each microservice should be handling one business requirement. Cohesive means that a microservice should have a single set of responsibilities. As a quick example, you might have a microservice whose job is to maintain mailing lists. And when a customer signs up, this microservice is responsible for storing their details, their mailing preferences, and so on. There might be some logic in there that says, no, this customer's an invalid customer and they can't be signed up because they've previously opted out of the list, things like that. And the service could also be responsible for broadcasting email newsletters. Well, okay, it could, but really handling emails is a totally separate requirement, it's a separate concern from the job of maintaining mailing lists. So I deliberately misled you there, really, because the broadcasting of emails would probably be a separate microservice. We'll call this the newsletter service. Of course, somehow these two microservices are going to have to collaborate with each other. The newsletter service needs to know which emails to send to. We'll be talking more about that later, but that's a great example where it's really easy to accidentally combine two separate business areas, email and list management, when they should be separate. The other principle is loose coupling, and this means that where possible, we need to minimize the interfaces between our microservices. It would be no good if the dependencies between the microservices look something like this. Now, maintaining loose coupling is hard, and I don't deny that. We have to be very careful in designing the interfaces and not letting them get out of control. And that's typically the job of a system architect who maintains a kind of overall view of how the microservices are fitting together. We're also going to see on this course that we can use messaging, and that can help us to loosen the coupling in the system. So more on that in the next couple of chapters. But what about the database? Well, this is controversial because, of course, many businesses, many projects depend on their integration databases. These databases might have been built up over years and years, and it could well be their biggest business asset. But for microservice architectures, integration databases are a definite no. So why is that the case? Well, it's because they immediately violate the two principles that we've discussed. They are by design not cohesive because they contain many different business areas. And they're certainly not loosely coupled because any part of the system can read or write to this database. And as it's an integration database, perhaps even other systems are going to be able to read and write to it. Now, I know that you can do things such as manage the user's privileges. You might have multiple roles for different business areas which have different read and write privileges. And of course, you might have a database which is broken into multiple schemas. But even with those features in place, I hope it's clear that we still have a major point of integration in the system, and that's going to cause a lot of coupling. So as I say, I realize that for many projects, that's a showstopper. If the integration database for you or your projects is a precious thing that you can't change, you don't want to get rid of it, then I don't really have any workarounds for that. Microservices are simply not for you. And that's fine. Microservices are definitely not a silver bullet that solves every problem that every project in the world can adopt. Well, of course, we're still going to need data stores, whether that's traditional SQL relational databases or NoSQL big databases, or maybe just persistent flat file storage. Whatever, the key thing is that each microservice will maintain its own data store. And that microservice will be really the only part of the system that can read or write that data. Well, this really is just the age-old principle of encapsulation that you'll be familiar with from object orientation, but it's being applied here at a higher level of the system. First advantage of this is that it's now no problem to have multiple types of data storage. If one microservice is best suited to be using a relational database, that's fine, that microservice would have that. If the microservice over here is better suited to using a big database, then it can use a big database. But that is going to mean that you're going to have to think differently about the data models. And it's going to mean that data is sort of spread around the system in a different way to the way that you might be comfortable with. A very quick and perhaps oversimplified example, but I hope it gives you the idea. In a traditional system with a monolith, you might have a user table containing the user's details, their address, and so on, together with their username and password. And in that monolith, you might have a routine somewhere that ships a product to a user, which is going to have to read that user table to find out the address to ship to. There'd be other requirements as well, though. We would, of course, have an authenticate routine where the user logs on, and this routine would be reading the user table to query their username and password. All that's fairly standard, and I admit I have certainly modeled systems like this in the past. But really, there is a mistake here. That user table, even though it's simple, is already incohesive. It's capturing two separate and totally unrelated business concepts. We have in there the user's identity credentials, username and password, and their physical location on planet Earth, their address. Well, in a microservice architecture, you would be forced to refactor away that incohesiveness because we can't have a single user table that's going to be read by two separate microservices. So we'd break it down. A possible solution is that we would have one microservice, let's call it principal management. I don't know if you're familiar with the term principal. That's a term that basically means user when applied to security. So this is going to be responsible for identifying a user's username and password and checking if they're valid. It's going to have its own data store, let's say an SQL database, but it doesn't have to be. And that's all that that service does. There's going to be a separate microservice responsible for order shipments. It would have its own table containing just the data relevant to the user's physical location, their address. So we might have a user table in here as well, albeit containing a different subset of data. We might not call the tables user in this microservice. It might be better to call that table principal. And in here, well, the table might be called user address. I don't really know. Well, actually, you can probably spot, and I'm thinking now that this shipping module probably wouldn't be responsible for managing users' addresses because the job of the shipping module is to do shipping and to schedule deliveries. So there's probably even going to be another microservice responsible for managing users' addresses. I don't know what this would be called. I'm just going to call it the address book service for the purposes of this caption. I haven't really thought through how this works. This service would probably have to collaborate with the shipping service somehow. Now, I'm just trying to illustrate there the kinds of thought processes you're going to go through. I don't know if any of this is correct because this system doesn't really exist and I haven't built this software yet. I just really wanted to explain that what you might have thought of previously as simple database tables are probably multiple concepts that are going to be modeled as separate databases in their own right. And it's worth mentioning then that when building a microservice architecture, I don't believe you can possibly do a big design up front. Microservice architectures are very, as we say, emergent. They tend to develop over time as your understanding of the system improves. So you will find yourself designing, building and deploying a microservice like the shipping one I did here, which ends up being incohesive and you realize it's doing too much. But it's only a few weeks later or whatever down the line that you have a eureka moment and you realize that no, that's too big, it's doing too much, it should be broken down. And that's fine, that's good, you refactor later. And I'm finding on my projects that's exactly the case. where on a Friday afternoon I design a microservice and I don't even realize that I've just accidentally combined 2 or 3 separate business areas together that I shouldn't do. That's not a problem. We refactor later. So agility is really important in microservices because it is impossible for any human being to get the right answer in advance of building the system. A jargon term associated with what I've just been describing is the term called bounded context. And I'm here on the Martin Fowler page because, as usual, Martin does a great job of explaining these concepts. But in fact, this is a term that originated originally in a book by Eric Evans called Domain-Driven Design. It's quite old, this book now. It's getting on for 15 years old, but it's still a recommended book. I must say it's perhaps not the easiest book in the world to read, but it really was full of some groundbreaking concepts that have influenced software development ever since. And bounded context was one of those terms. And really this jargon term means what I've just been describing, where we have large models that have been divided down into different, what he calls bounded contexts. And a bounded context is where you have data purely for one specific business area. So there's a nice example here where this previously monolithic data model has been broken down into a data model for the sales area or context and a data model for the support area or context. And you can see that there is some apparent duplication in that there's a customer table in both of them, but these will be different customer tables. There will be different data relating to a customer for support as to what we would see in the sales customer table. So although domain-driven design predates microservices by a long way, you can see that these bounded contexts would make ideal databases for a single microservice. So do check out the Martin Fowler page or the domain-driven design book if you want to read more about that. Generally, bounded context is not a term that I feel comfortable using because it feels a bit jargony. I just hate the word context. We seem to overuse that in software development, but it's certainly a term that you're going to be hearing a lot in the real world. So on this course, we're going to be building some microservices using Spring Boot. As you can probably guess, you can develop a microservice using any programming language or framework. And you could build one microservice using Spring and Java. You could build another microservice using Python. You could develop another microservice using, I don't know, Scala or Clojure. As long as these microservices can communicate with each other, it really doesn't matter what language you're using. However, I think that Spring Boot is especially well suited to the task of building microservices. So we're going to be building a few on this course, but really the interesting part of microservices is not the services themselves. It's the overall architecture, which is how the services fit together and how we develop them properly and also how we deploy them. Now, I've designed this course to be primarily a course for developers. So I'm only going to be looking very briefly at deployment on this course. There will be future courses where we do look at how to deploy the system. And you definitely do need a lot of tools and support to do a microservice architecture. Ideally, for instance, you would have separate code repositories. You would need some kind of continuous deployment system such as Jenkins. And on my projects and the projects that we'll be doing on this course, we would have totally separate Eclipse workspaces for each of them. Now, because you're going to have a lot of microservices, Netflix, for instance, report that they have over 600 microservices on their system, you have to automate all of this. So some kind of automated deployment system using tools such as Puppet, Chef, or Ansible would definitely be needed. So they will be covered on future courses. But for this course, as I say, we're going to concentrate on developing the microservices and stitching them together. So I hope that's a good overview of microservice architectures. In the next chapter, we're going to get started. We won't be doing microservices immediately, but we will be looking at how to send and receive messages using Spring Boot.